has been to a Mountain West Ruby conference before this year? All right. Oh, wow. So about half. So hello again. All right. So I did Mountain West. It was a thing. It was a lot of fun. And then I killed it because you have to kill your darlings, I guess. So I'm going to talk about machine learning. So this is me. You probably see me around. So Mountain West was a thing. I'm really proud of it. And the reason it started all those years ago is because I went to Ruby Conference 2005, and it like melted my brain. And it was a terrific experience, and still, like, to this day, one of like the seminal experiences of my programming life. And I really wanted to be a part of it. So the next year, I submitted a talk proposal, and they didn't accept it. And I was kind of bummed about that. And about that time, I ended up getting transferred to Utah. And I met up with Pat Eiler and some other folks, and they were saying, you know, we should start a regional Ruby conference. And I was like, yes, we should, because then I could give my talk that I really wanted to give at RubyConf 2006. So, you know, we went through the entire organizational hassle, and I'm sure the organizers know how painful that can be. And we really hit the pavement. We went out and searched for good speakers to submit proposals. And then when it came down to everyone was going to vote on the proposals, we're going to create the schedule of what we wanted to see. And I put my proposal was like the first in. I was super excited. And then I was voted dead last because they said I had an unfair advantage for being an organizer. And then we actually had to do the conference. And after that first experience, I know I didn't have time to ever actually talk at it. So I've never spoken at a Mountain West RubyConf, and I'm excited to speak here. So anyways, that's a very long way of saying that I am, in fact, a very big deal. So thank you. Yeah. Apologies if you don't like visual puns. Deal with it. Every time. Every time. Yeah, it's going to be there forever. All right, so we're going to talk. The title is Leveraging Machine Learning for Awesome. And I've talked to a couple of folks, and they said, like, oh, I'm moderately interested in this topic, and I hope that you're going to cover X. And I'm not, because you're misreading the title. But this is my experience as I was getting ready this week. I'll let you read that. So if you've seen me the last couple days, been out in the outside working, that's because I've been working on this talk. And then here's today. So. I'll give you guys a few moments to really soak in that joke. Got my phone on me. I don't know what time it is. All right. So machine learning. What is machine learning? Machine learning is one of those things, if you're ever in a Silicon Valley elevator and a venture capitalist walks in and they're like, give me your pitch, you drop machine learning because it makes you sound awesome, right? Right? That's true. All right, so because it's so hot right now, everyone loves machine learning. But the real big question about machine learning is how damaged are we going to be once the robots take over? And the great news is that this is what it's going to be like when the robots take over. Right? Watch right here. Boom. Right? It's dumb. Machine learning is very, very useful, but it is not a panacea. It is not Skynet. It's not going to take over anything. And we're totally in charge of it. So we're going to talk about how we learn against the machine, how we're going to go about it. There's really a few simple steps. The first is to gather data. Now, if you've been anywhere in the industry the last 5 years, we've been talking about big data, right? Which basically means anything you generate or anything you observe, you have to save, right? Petabytes and petabytes of log files, right? What are you going to use that for? The answer is we don't have no idea what we're going to use it for, but we need big data, and so we've got it. Well, this is a way to use big data, right? So think about what you can observe and make note of it, okay? After we've collected data, the next step for learning the machine is to organize said data into models. Now, I've got, and the way we do that is we use numbers, right? And what you're going to do is you're going to model all of your data into numbers, and then we're going to manipulate those numbers with maths. So who here has kids? Most of us have kids, great. I have kids. My youngest is 8, and 8's a wonderful age. One of the things I love about 8, and we had this before with tic-tac-toe, right? I love playing tic-tac-toe like in a restaurant with my kids. And 8 years old is the perfect age because they're really coming into their own. They're understanding the world. They're understanding that they have a good idea about what they know, and they have a good idea about all the things that they don't know, and they're on a mission to turn the unknown knowns into the known knowns, right? But they're oblivious to their unknown unknowns, right? They have no concept of things that are outside of their current basis of understanding. And tic-tac-toe is one of these great things because you can just like school them every single time. What's so great about my boy is that he has this perfect confidence that he can totally beat me. In fact, I asked him this morning, I said, Tom, do you think you can beat me in tic-tac-toe? And he's like, absolutely, I know I can. I've done it before. And, you can't. It's great. So talking about modeling data, we're going to model a tic-tac-toe game. And we're going to do that by giving each position on a tic-tac-toe board a number, right? Because it's all about numbers. You just have to collect numbers. The numbers have to mean something. They have to be consistent, but it really doesn't matter what number we use. But we're going to use the positions, right? And then after we collect all of the moves in a tic-tac-toe game, we're going to add another number, and that's going to be whether or not the first player won, lost, or tied, basically, right? So my boy always makes the exact 2 mistakes every time we play. The first is he lets me go first, right? And so when you go first, you always take that center position because it's really difficult to win without that center position. But he's convinced that he has my number, right? Because he wants to replace me. That's his goal. And, I have to assert my alphaness and say, no, you can't do that. So he lets me go first. I choose the middle. That's position 4. So we're going to add 4 to our list. This is, again, we're modeling a tic-tac-toe game. Now, he makes his crucial second mistake where he loses the game. There's literally no way to win this game after he chooses that top middle position. And I'm convinced he chooses that top middle position because he just saw me choose a middle position. And he's like, oh, I got to do a middle like Dad because I'm going to beat him. He chooses that one position, we add it to the list. At this point, the game's over. And the only thing I'm thinking about is whether or not how much I'm going to gloat about this or what I'm going to extract out of him out of bargaining and betting that he's going to beat me because he still thinks he's going to win, right? I take the corner that he should have taken, add it to the list. This is the third step, right? At this point, my son is freaking out because he didn't realize that after 2 moves, I could actually have a potentially winning, position here. So he quickly jumps all the way down to position 8 to block me, right? Thinking that the threat has passed, right? Now I feign like I really have to think about what my next move is. I take 6, the other corner position, because corners is how you win tic-tac-toe. Now he sees that I can go diagonally to win, but he also knows that if he takes position 2, so he takes position 2, we add it to the list. Now he's in prime position to take that rightmost column, right? He's getting pretty confident, and he's completely unaware that I'm just going to take that left column and it's over, right? So I take the left column, position 3, we add it to the list. Now we have our 7 moves. This defines our game. And then we add a 0 because I totally beat him at tic-tac-toe. I've asserted my manliness, right? All right, so if you can model a game of tic-tac-toe at a restaurant, you can totally model most everything that you want to observe, right? All you have to do is come up with what the numbers mean, represent them with numbers, and keep that list. The next step of learning the machine is to identify clusters of data, okay? Now, we're not going to do this directly, but it's important to understand how this works. Lots of machine learning will use something called the k-means algorithm. And what that does is it finds related pieces of data. So let's assume for a moment we've got a set of 2-dimensional points. That means we've got an x coordinate and a y coordinate, and we have a bunch of them, right? And we chart them on a chart here. We plot them all on the chart. And what we want is we want to group them into clusters. Now, visually, it's really easy for us to kind of draw lines around it. But algorithmically, it's a little more difficult to come up with how we do that. And that's where k-means comes in. K-means is an algorithm that takes how many types of clusters, the number of clusters you want, and it will try and group them into the most efficient clusters. And when it operates over this on a k of 3, we get these types of clusters. Now, this is incredibly useful, but choosing the right k is kind of the trick, and there are a lot of different ways that we go about it. This is a 2-dimensional array. But if we go back to our tic-tac-toe game, we've got an 8-dimensional array. So thought process-wise, if we added a 3rd dimension, we've got a cube, right? If we had points within a cube, you could probably draw spheres around the different clusters, right? You can probably like say this is this cluster and this cluster and this cluster. But how do you do that over a 4th dimension, right? How do you do that like over time? Can you draw something over time? What happens if it's an 8 dimension? That's what makes k-means so interesting, and that's kind of like the basis of machine learning as it's implemented now. And what I'm going to talk about tangentially here is an open source project called TensorFlow. TensorFlow is Google's machine learning product, completely open source at this point, that takes multi-dimensional arrays of numbers and will run calculations on them. That's basically what it does, but it does it in like the most scary way possible, using your GPU and custom semiconductors or chips and stuff now. That is scary, But it's really great. The way TensorFlow works, can I click on TensorFlow? Nope. Here, let's Control F1. Thank you, Aaron. All right, let's click on TensorFlow. This is the website for TensorFlow, right? It's all nice and orange, which is the best color in the world. The description here says it is a library for representing mathematical operations with flow graphs, right? And so the edges of the graph represent the multidimensional arrays, and then the nodes represent the calculations you're going to run on them, okay? So let's go back here. So what that means is you're going to build a graph, like a tree. Trees is a form of graph. And you're going to put all of your data into the leaves, and then your nodes, you're going to be like all the different calculations, and it's going to flow through and do all the calculations. It doesn't do it while you're setting this up. It does it after the fact. And what's great about TensorFlow and machine learning is that Google actually has a service, a hosted machine learning service, where you can like load all of this data up into the system and then click a button, and then it'll run on those cloud servers. You never have to do it locally, but you can do it locally. And you can do it, okay, the other thing, this is kind of a strained metaphor here, but Redis is really popular in the Ruby community because it takes some really key functionality out of the Erlang platform and exposes it so that we can learn it, you can use it within Ruby. And I like to think of TensorFlow as taking out some really useful things out of Fortran and putting it so that we don't have to actually do everything in Fortran. So there's a lot of math in Fortran, and TensorFlow is actually uses a lot of that because it's really difficult to write that elsewhere. In Ruby, we can go ahead and use this TensorFlow RB project. Oh, come on. All right, I'll just Google it. So Google does not have a first-class Ruby implementation, but the community has stepped up and created a, see, this is why I wanted Ethernet here, has created a Ruby gem that uses the C++ interface for TensorFlow, and it wraps it in Ruby. It's really difficult to install because you actually have to install TensorFlow. They also give you a Docker container, so you can just download said Docker container, open up a bash prompt, you're in it, and you've got the Ruby gem. You can do all that type of stuff, okay? Now, here is what the code looks like when you're going to be doing TensorFlow in Ruby, right? Those leaves of the graph, that data, those are called tensors. And yeah, I don't know. Is that interesting at all to anybody? I don't know. It's rough. Let's go back into this. All right. Once you get past that, you use this cluster of data that you've got with TensorFlow for profit, and that means underwear, because why wouldn't it? The point here is that machine learning is not artificial intelligence. Machine learning is you're creating correlations, you're recognizing patterns in data in a way that is not obvious, right? You get into like, eighth dimensional kind of pattern matching and stuff like that. Whereas artificial intelligence, up front, you're creating all the rules and telling it, how you want to play the game. So the tic-tac-toe example, right? You take a bunch of data about how you win or lose at tic-tac-toe, and then you let the pattern matching tell you what you should do next. Whereas in artificial intelligence, you're saying, here are all the rules up front, and then just run the game against those rules, right? So it's different. We're not up front deciding what things are what. We're kind of observing that over time. That's the real big difference. Basically, it falls into linear regression fitting, and right, like, I don't know, that's complex. I don't want to do that. All right, let me go back into my notes so I can talk about this. Here we go. All right, so if I was a real presenter and I had my talk done before yesterday, this is where I would show a lot of the mathematical formulas upon which all this is based. But it's hard to do. I could go into a deep dive in TensorFlow and make sense of all that code, but honestly, I don't even understand it, right? Like, this is why everybody here has been misunderstanding the point of my talk. It was not to go into machine learning, it was to leverage machine learning for something that is cool, right? So, oh, I don't know how they got in there. Anyways, yeah, it's like, what are we gonna do? Anyways, my point is that this talk is slowly or rapidly veering off into the not awesome category, and the title is Leveraging It for Awesome. So let's talk about things that are awesome. What's awesome? What do you guys think is awesome? Anybody? Video games. Video games are awesome. Who wants to watch a video game?
I have a feeling that was.
All right, so let's go look at a video game. All right, so okay. I didn't pay anybody. I don't know what you're talking about. All right, so let's play a video game. I made a Asteroids clone, but very highly branded to Ruby. So let's go ahead and run that. I can show you the code if you're interested. Oops. Don't worry about this other command. You're not going to have that on your system. Okay. All right. Here is my Ruby clone. It's really super hard. What you basically do is you use your arrow keys to avoid asteroids. And it's actually not super easy, but it's stupid, which is kind of the point of video games, I feel like, right? Dang it. Anyways, there's a certain amount of randomness in the movements too, so just to keep it a little more interesting. So that's awesome, right? Yay? Yay, video games. All right, but it's not machine learning. So let's talk about machine learning. Google does a lot of machine learning, actually. And they're using machine learning in some really interesting ways now. And one of the things they're doing with machine learning is they're exposing it to consumers, and they're doing that in a variety of APIs built on their Google Cloud platform, which is like their version of AWS, right? But it's more than just AWS. It's more than just virtual private servers and private networks and stuff like that. They're doing a lot of other things as well, and some of their APIs on the cloud platform are actually powered by machine learning by this giant TensorFlow machine behind all of it. One of them, they've got a speech recognition API, which is pretty cool. They've also got image analysis, right? So is this picture a cat? Google will tell you, and they're using machine learning to do that. And then also natural language processing, stuff like that. So let's, and actually this stuff is actually really pretty awesome. And it's really incredibly useful. So let's take a look at speech.
Hello, RubyHACK.
All right. That is an audio file that I've got up on a URL there. And it works. Everybody heard it, so that's cool. So let's go over to the cloud.google.com speech website. And what I want is I want to do the speech recognition on that WAV file in Google Cloud Speech. So you can look at all the documentation. Not awesome. Let's go look at the console. When you sign up, you get like a year worth of activity. So that's pretty cool. Let's look at speech here. All right, so this is like all of my use of speech, and I don't have a lot of it kind of in the last 6 hours. But if you go to like the last 2 days, you'll see some spikes of activity. That was me in the hall. I'm going to click on this. This is really hard to see. I'm going to click on this, try this API in the API Explorer. So this is a web-based way to call the API without doing anything else. Speech is a really simple API. There's not a lot of endpoints you can hit. Actually, instead of doing the V1 beta, let's just go to V1. No. Really? But you worked yesterday. What am I in? Here we go. All right. Stop it. All right, so we're going to go to the recognize. There are basically three different ways that you can call speech. You can call recognize, which will do like an asynchronous recognize, or a synchronous recognize. It'll process the file and give you the result. You can do an asynchronous or a long-running recognize, which you can give a larger file, like up to an hour, I think. It'll go and process all of it, and then once it's done, it'll let you know, and then you can get that translation, get the text from it. And then you can also stream up to it. But I only really care about recognize, because I'm going to give it that file. So here I'm going to say, here's my audio, and I want to give you the URI. And in that URI, I'm going to go ahead and take that URL that we just played, because that seems like that'll work, right? And then I'm going to add a configuration, and I need to tell it that we're talking with American English. Okay? Now, that seems like it would work, right? Let's click on it, authorize, and it's not. I got an error. And the reason I got an error is because it doesn't like that URL. Google has a different URL scheme for storage URLs. So you have to give it its own URL. So GS means Google Storage. The host is the bucket, and then the file path is the file. Who knew, right? But that's the way it works. Let's click on it. It works, and it says, hello, RubyHACK. Yay! Look at me begging for applause. All right, cool. Closer to awesome, but what can we do that in Ruby? And we can do that in Ruby. So let's just go here into IRB. Okay. Oh, how do we do that in Ruby? I guess I should answer that question, right? How do we do this in Ruby? We install the Google Cloud Speech gem, which is what I've been working on for the past 2 years, this whole suite of gems that expose the Google Cloud API. So please, by all means, go out and use it. And just look how awesome and easy it is to use. Okay, so now I'm into the live coding portion of the talk. So yay for me. So I'm going to require Google Cloud Speech. I'm going to create a new speech object. Oh, I got my equals. Yay, live coding. Okay, so I've got my speech object. Now, I've already done and installed like all of the authorizations, so it knows who I am. And so what I'm going to do is I'm just going to call, I'm going to say results equals speech.recognize. And then I'm going to give it that URL, that weird URL that we created, which was hello.wave. And then if the demo gods are with me and the network is with me, it'll work. Nope. I made the same mistake. I didn't do language. OK. Does it work? It works. Look at that. Yay. Closer to awesome, because we're using Ruby, but not awesome enough. We need to make it more awesome. We need to actually send it my microphone and have it translate. I think that's awesome. How much time do I have? All right. 15 minutes. I can do this. All right, so we're going to use a different library. We're going to use Core Audio. Core Audio is a Ruby gem that connects to the Mac system to grab your audio stuff. So I'm going to use that. So let's go ahead and we're going to open up a brand new file here, and we're going to call it speech.rb. Okay? And we're going to require Google Cloud Speech. All right? And we're going to create our speech object, which is Google speech.new. Okay. Now, in order to get the audio, I also need to require the other library, which is Core Audio. Yeah. I'm going to create two objects. First is going to be an input device. Okay. And that's going to be Core Audio default. Yeah. Which is my default input device. Okay. And then I'm going to create an input buffer because I need to buffer all of the bits that are coming off of the device into something that I can read from, and that's just input device dot input buffer, and we're going to give it a magic number of 1024. Okay. You can play with all this on your own time. So what we're going to read from that buffer, it acts just like a normal I/O object, and we're going to get an object that is an N array, which is not a real Ruby array, but it's like a numerical array. And we're just going to cast it to a real array and then use that. And it's going to return an array of a multidimensional array, and each element in the first array is going to be two numbers, one for the left channel and one for the right channel, because it's a stereo input. We only need the one because speech only wants a mono input stream, so we'll get to that. The next thing is I'm going to create a stream object, okay? And that's going to be by calling speech stream, and then we're going to tell it a little bit about the data that we're giving it. The first is that we're going to use the linear 16 encoding format. This basically just means that we're using little endian bytes, 16-bit bytes, right, that represent our data. The second, we got to do that language again because I'm always forgetting that. The last thing is we need to send it the sample rate. Okay, and that's just going to be whatever the input device is their actual rate, which I think is like 44,100, something like that. Cool? After we do all that, we're going to start our input buffer. Okay? And then once we get our input buffer started, we can pull off that input buffer and then send it to the stream endpoint, and then it'll start doing the speech recognition. Okay? Now, how long we do that is kind of up to us. What I'm going to do is I'm just going to pull from it 25 times, which will give us about like 4 or 5 seconds. Okay? So we could do like a more infinite loop if you wanted to, or we could have some sort of outside thing that would break the loop for us and tell us that we really, now we're ready to stop the stream. But we're just going to do kind of a timed thing. I'm going to call break if the stream is stopped. Otherwise, we'll get an error, right? So if something outside of this loop breaks the speech stream, then I want to break the loop. That's kind of a guard. What we're going to do is we're going to get all of our bits, and we're going to get that from our input buffer, right? And we're going to read 4096 bytes at a time. Now, again, this is an N array, so I'm just going to convert it to a Ruby array, and then it's an array of arrays, and I only care about the first number, so I'm going to map over each element of that array, and I just want to pull the first number in, okay? So if it gives me an array of 1 and 2, then I just want that to be 1, right? So now I've got an array of bytes, or of numbers, of just random integers, right, that represent the audio stream. I'm going to change that into a sample. I'm going to do that by taking my bits, and I'm going to pack those numbers as the byte representation of a 16-bit signed little Indian number, right? And that's what we're going to send on up. And you do that by calling pack on an array, and you give it the type of packing you want it to do. And we want to do a little Indian 16-bit integer, which was S. And then we're going to do that for all of them, so we're going to add a star, okay? So this is going to give us a string. And then we're going to take that stream, and we're going to send that. We're going to send that sample. Whoops, not send, sample. We're going to send that sample back up. Cool? Make sense? Once we're done, I can't type. We're going to stop our input buffer. We're going to stop our stream. And, no, not stopped, stop. Okay, and then the next thing we're going to do is we're going to wait for the recognition to complete. And that's going to be using wait until complete, which is a little bit of a helper method that the Ruby API gives us. Huh? Until, yeah, that's nice. Live coding is my favorite thing in the world. Results is what we're going to get from the stream. And yeah, and then we're just going to put S the results. First.transcript. We probably just could say transcript because the result object will convert it to a string. But anyway, here we go. So less than 30 lines of code. This is going to read from the microphone and send it up to Google. And then Google is going to use machine learning to tell me exactly what I said. Remember in the old days where you just had to train the voice recognition by say a lot of things and stuff? It doesn't do that anymore because it's so good. So here we go. Did I not save it? Speech, not stream, thank you. All right. Cross your fingers and toes. Hello, RubyHACK. Ah. Live coding is the best coding. Yes. All right. All right, better, more awesome. Awesome in a different way than video games are awesome, but still awesome. I'm not ready yet. We can up the ante, right? So let's go and let's look at this API for speech. Because there's a thing that I want to do. So now we look at the boring documentation. We go look at the API reference for speech, V1. Don't use V1 beta 1. Use V1. When we create a streaming recognize request, right? We give it our config. That's like the audio file or the language and stuff. And then we're going to start sending it bytes. but in our configuration. It's more than just the language that we were having before or the type of encoding. We've got a couple of additional values. One, we can tell it to return once we get our single utterance, right? So if you say hello or whatever that first utterance is, it'll stop the stream. That's not useful for us. But the other one is it will return interim results as you're speaking, right? So it'll record for a while, and instead of returning all the results at the end, it'll give you interim results as you're using it, right? That's pretty cool. So would it be possible to hook up speech to the video game and then use your speech to control the video game? Would that salvage this talk for anybody? Can we do it in 4 minutes? I can do it in 4 minutes. All right, so we've got our code here. Let's look at the code. In our play class, this is the level. What we're doing is whenever you push the button down, we're moving the player left or right or up or down, right? The player then is going to be moving around. This is a lot like what Ryan was showing. But then we've got this collide method, and we're giving it all of the rocks that are floating out in space. And if we end up colliding with it, then we're going to call die and return true. Otherwise, we didn't collide and return false. And then our play, when we call update, it's going to, hey, are you colliding? And if you're not colliding, then we're fine. But if you die, then we're going to end it. So let's go back and look at that one more time. Nope, sorry. OK, so here you go. So I'm just pressing keys. And then I collided. When I die, it plays the sound, and it stops. So what would it look like if we added speech? And through the magic of awesome conference programming, we're going to check out speech. And then look at the code again. So so this looks very, very similar to what we had just done before, right? On the initialize, we're creating an input buffer from our input device, our default device. We're creating a new speech object, and we're creating that stream object, right? Now, I've added a couple of extra things. First is we're going to ask for interim results. The next is we're going to kind of seed it with the phrases that we're looking for. That's going to help the speech API know kind of what we're doing. And then on that stream object, we've got this onInterim method that will give it a block. This is how we're going to do those callbacks, right? This is asynchronous node-style programming in Ruby. It's been there since the beginning. It's not a big deal. When we get an interim result, we get two objects back. The first is the final results, which is the stuff that the speech API has agreed upon and said this is real and you can trust it. The next is interim, and it could give you all sorts of different interim results. Since we only care about what we're saying at the moment, we're only looking at the interim results, we're going to take the last interim result, and then we're going to split that string by space, and we're only looking at that last word, okay? And that's how we're going to try and get, hopefully, a more, a quicker response from the speech API. If you say left, right, up, or down, we're going to call player left, right, up, or down. Make sense? The other thing we're going to do is we're going to, right here on line 30, we're going to print the entire interim result and then what we actually kind of pulled out of it, right? What we're actually going to do. That's so you can kind of see how the speech API is working, because sometimes it gives you some interesting results as it's trying to figure out what it is you're actually saying, okay? If there's an error, then we're going to go ahead and print the error stuff. When we start it, this is where we're going to, when we start the level, this is where we're going to start the stream and the buffer, and then we're going to create a thread. And the reason we create a thread is we want this to happen not on the game loop. But because we are doing this recognition not on the game loop, we need to synchronize back over to the main thread in order to tell it to stop and stuff. That's where these synchronize methods come in, right? Those synchronize methods come from the monitor library, which is part of standard Ruby. That helps us talk across threads. All right? So we're going to create a thread. We're going to stand up all the bits that we're collecting from the microphone. And then on the interim results, we're going to pull those out and move the player. Cool. There's a couple of other small changes. We added a stop method so that we can stop the stream if we need to. And then when we collide, we're going to stop. We're not going to listen to it anymore because I don't want to. I'm having to pay for a lot of this, so I don't want to send that much data. So that's basically all of the changes. And let's see if it works. Left, or up, up. I said rup. Left, left, right, right, left, up, 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 up. All right. So again, interim results, you can kind of see what the speech API was starting to recognize. Now this is happening as I'm speaking, so I may not actually be done with the word before I start getting results. That's what's really cool about this, right? So when you're talking into your phone and it's like dictating what you're saying as you're saying it, this is what it's using, right? So, not to beg for applause, but was that awesome? All right, cool. I started a couple minutes early or late. Ask me anything. If you ask me a question, it doesn't have to be related to this. It can be about anything. I will show a funny robot fail video. Yes?
When is the League of Legends API coming out with voice control?
When is the what?
League of Legends API with voice control.
League of Legends API with voice control? I don't know, man. You have to have like a profanity filter on it, I would think. I don't know. It's fun. It's a silly, stupid little thing, but it totally works. And I'm not very smart, and I got it to work, so I mean, that's pretty cool. Any other questions? Yeah?
In one of your demos where you said, hello, RubyHACK, the R came back capitalized, so it was a proper noun. Is that something you set up, or did the speech API do it, or did it learn?
Speech API recognized it, yeah.
It recognized it as like a proper noun.
As a proper noun, capitalized it.
Capitalize HACK.
Yeah, it didn't, because I have feelings about that, so. All right, yeah.
Do you need a sticker?
Do I need a sticker?
Yeah, I have crystal stickers and Peter J stickers.
I will trade you a sticker for a sticker, yes.
Okay.
That's good.
I already have 3 of your stickers on
All right, I've got some in my bag too. Good question, I like that. If you want a sticker, come and talk to me, I'll give you a sticker, yes?
How much is it setting you back monetarily?
How much is it setting me back? That demo was probably like 12 cents. So, but yesterday I did it a lot more, so it was probably more like $1. Yeah.
Just a comment, in tic-tac-toe, the first best move is actually one of the corners.
The first best move is the corner.
When you take the center, they can go in any of the corners to avoid instant loss. But if you take the corner, there's only one place they can go to avoid instant loss. So, yeah, if they take the center. But then
Challenge accepted.
Yeah. I'll put you up with my 8-year-old and you can teach him that. Okay, so the videos, the GIFs actually get funnier as it goes on. Some more questions? Yeah.
Did you pick tic-tac-toe because of war games?
Did I pick? Oh, I forgot my War Games reference. Yes, I did. I was going to drop, do you want to play thermonuclear war? Yes, no, there was a planned War Games reference, and I missed it. Yeah. We can let this go for a while, actually. Any other questions? Yeah. Yes, we can have another GIF, sure. This is a longer GIF, and so it'd be better if I was answering a real question on that, other than yes. Here comes Junior. All right. Any other questions? Anybody? I got a couple more. There are a few more gifts. Yeah.
What are some of the other, so you showed speech a lot, what are some of the other things we can do, the types of uses for them?
What are the other APIs that are built on machine learning? There's an image recognition, right? So I can see that being really useful if you wanted to detect something that was like a non-safe image. You know, like they will rate images for violence or, you know, nudity and stuff like that. And so that I can see that being, and that from just what I've seen, it's been very, very useful. There's a lot of folks that are actually using that. Speech is a little more difficult because it's kind of, it's not that esoteric, it's just kind of harder to get set up and it's a little more expensive and stuff. I think vision is the one that's being used the most. That's the one that does all the image stuff. But it'll tell you, like, you can give it an image and it'll be like, that's Mount Rushmore. And you're like, man, how do you know that? You know, like, how do you know that that's not just like an image of a couple of guys or 4 people, right? But they'll say, no, it's actually, that's a landmark, that's Mount Rushmore. So, again, it's doing that just by like looking for those patterns and numbers, right? Do they have handwriting? Yes, they've got OCR as well. And so you can use Vision to do OCR. I think either they're about to update or about to release. They're either about to release or just released an update to the Vision API that is specific to OCR. And so, yeah. And folks use that for like looking at receipts and categorizing the receipts, stuff like that. Faxes, yeah, no, again, you should take a look at it because it's pretty easy to use. Use the Ruby gem, and you can do awesome stuff with Ruby. Okay, one more. Anybody else? Yeah.
Sorry, sub-question to that OCR. Is Tesseract the Google OCR library because the open source? I think that's where that came from, isn't it?
Is Tesseract the...
Tesseract, yes, it is. Okay, that's the same one.
Yeah.
They haven't open sourced any of the other ones, have they?
I don't know what they've open sourced. Yeah. All right. I was going to use this earlier for like our robot's going to take over the world. So I like that one as well. And then I think this is Jason's favorite. You're going to turn that valve really slowly, methodically. Yeah. The machines can be smarter, yeah.
How long did you spend searching for all these gigs?
How long? I found a Bloomberg article that linked all of them, so I spent all of like 3 seconds on finding them, so yeah. All right, guys. Well, thank you very much. It's been my pleasure to be here.